Hello and welcome back. In this tutorial, I will show you some tricks and tips on some basic single output designs that you can do using the software. We will manipulate the custom component sets to channel the power of the software and zero in on a solution. Let's do a tiny switch 3 based design. Let's select the universal input voltage range and let's enter a 5 volt 2.5 amp design. To begin with, let us see what the software will output by default. We'll maintain all the default values like the main turns and the core size range. As you can see, all the top solutions use the EE19 transformer core and all the solutions have the same number of turns. Each design, however, has a different diode selected, which for a single output design may not be all that important as it will be a regulated output. Thus, all the differences in the forward voltages for each of these diodes will be corrected for by the feedback control loop. So it would be nice if we could ask the software to present us with as many designs with the same diode as is possible. This can be achieved by specifying a custom component set wherein we can specify just which diodes the software can use. One of the diodes used in these top solutions was the SB360, which is a 60 volt 3 ampere Schottky. Let's fix this diode and ask the software to design around this particular component. So let's go ahead and close this design without saving it. Under the Tools menu, click on Component Sets. This opens the Component Set Selection dialog. Let's create a new set by clicking the Create Set button. Let's give this component set a name. I am going to call it Limited Diodes Component Set. Under the Diodes tab, you can see all the diodes that are available in the default component library. There are various types of diodes available. Some fast PN diodes, some Schottky diodes, standard recovery diodes, and some ultra-fast recovery diodes. Since the diode we want to keep is a 60 volt Schottky, let's first use this filter and uncheck or deselect all the ultra-fast diodes. We will do the same for the high voltage Schottky, which are the 80 and the 100 volt Schottky diodes. Click yes on the pop-up, which is asking us if we are sure with the changes that we have just made. Let's do the same with the low voltage 25 volt Schottky and the same with the 45 volt Schottky diodes. With the 60 volt Schottky diodes, we will be sure that we are selecting the SB360 diode, which is the diode we want the software to use. With all the diodes selected on this list, we have fast diodes in there, the one Schottky diode that we wanted, and standard recovery diodes. It is important that we keep the standard recovery diodes inside this custom list because the input rectifier diode is chosen from amongst this group of diodes. The same applies for fast PN diodes as the blocking diode in the clamp circuit is selected from this type. So it's important to include these two types. With these changes made, let's click OK. We have now defined our custom set. Let's now redo the previous design, which was a tiny switch 3 based design. It used universal input voltage range, and let's add the output, which was a 5 volt 2.5 amp output. In the design settings dialog now, let's be sure to specify to the software to use the limited diodes component set, which is the one that we just created. Click Finish. Let's keep the same settings for the turns and start and end point for the core sizes that the software will iterate through. Notice now how all the designs use the same diode, which is the SB360, just like we had wanted. But now see how you have a nice variety of designs with different combinations of core sizes and turns that you can choose from. Let's go ahead and select any design. I will open the solution with the EEL19 core. I happen to know that this design will make use of margin tapes and avoid the use of triple insulated wire. We do hope that this tutorial has been helpful and will make your experience with the software a positive one. Thank you very much and good luck to you.